Yes, number 6 American wire gauge THHN or THWN wire and larger, stranded, green in color, is rated for equipment bonding and grounding in a free air installation exposed to the elements, but not subject to physical damage, according to the National Electrical Code, or NEC. The National Electrical Code specifies the requirements for electrical wiring and equipment to ensure safety. Equipment grounding conductors, or EGs, play a vital role in providing a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices like circuit breakers and fuses. The use of green insulation on grounding conductors is a universally recognized standard, helping to easily identify these conductors within an electrical system. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. Table 250.122 in the NEC provides guidance on selecting the appropriate size of the EGC based on the rating of the overcurrent device. For example, if a circuit is protected by a 20 amp overcurrent device, the minimum size EGC required is number 12 American wire gauge copper. If the overcurrent device is rated at 60 amps, a number 10 American wire gauge copper EGC is needed. If the overcurrent device is rated at 100 amps, a number 8 American wire gauge copper EGC is needed. And if the overcurrent device is rated at 200 amps, a number 6 American wire gauge copper EGC is needed. THHN and THWN are common types of wire insulation. THHN stands for thermoplastic high heat resistant nylon, while THWN stands for thermoplastic heat and water resistant nylon. Both types of wire are suitable for use in dry and damp locations, but THWN is also suitable for wet locations. The ampacity of a conductor, which is its current carrying capacity, is affected by several factors, including the ambient temperature and the number of conductors bundled together. The NEC provides tables such as Table 310.16 that list the allowable ampacities of conductors based on their insulation type, size, and temperature rating. When conductors are installed in free air, they typically have a higher ampacity compared to when they are installed in conduit or cable because the free air allows for better heat dissipation. However, it is crucial to consult the appropriate tables and correction factors in the NEC to determine the correct ampacity for the specific installation conditions. The term free air refers to an installation where the conductors are not enclosed in conduit or cable and have ample space around them for heat to dissipate. This type of installation is common for overhead power lines and some industrial applications. When conductors are exposed to the elements, such as sunlight and rain, they must be suitable for outdoor use. THHN and THWN wires are generally suitable for outdoor use, but it is essential to ensure that the specific wire is marked for outdoor use, such as THWN-2, which has enhanced moisture resistance. While the wire may be suitable for exposure to the elements, it is important to ensure that it is not subject to physical damage. Physical damage can occur from a variety of sources, such as impact, abrasion, or exposure to chemicals. If the wire is subject to physical damage, it must be protected by conduit cable trays or other suitable means. Equipment bonding is the process of connecting non-current carrying metal parts of equipment together to create a low impedance path for fault current. This is important to minimize the risk of electric shock and to ensure that overcurrent protective devices operate properly. Bonding is typically achieved by using bonding jumpers, which are short lengths of wire that connect the metal parts together. The size of the bonding jumper is determined by the size of the circuit conductors. The NEC provides guidance on selecting the appropriate size of bonding jumpers in section 250.102. Grounding and bonding are essential for electrical safety. They help to protect people from electric shock and to prevent damage to equipment. It is important to understand the requirements of the NEC and to follow them carefully when installing electrical wiring and equipment. The use of green insulated wire for equipment grounding conductors is a long-standing practice aimed at enhancing safety and minimizing the risk of electrical accidents. The clear and consistent identification of grounding conductors simplifies installation, maintenance, and troubleshooting procedures. Electrical workers can quickly identify the grounding conductor and ensure that it is properly connected to the grounding system. This is especially important in complex electrical systems where there may be many different conductors present. Furthermore, the use of green insulated wire helps to prevent accidental connections between grounding conductors and other conductors, such as phase conductors or neutral conductors. Accidental connections can create a dangerous situation that could result in electric shock or equipment damage. In addition to the color of the insulation, the NEC also specifies the marking requirements for equipment grounding conductors. Equipment grounding conductors must be identified by a continuous green color or by a green color with one or more yellow stripes. The markings must be visible throughout the length of the conductor. The NEC also allows the use of bare equipment grounding conductors in certain situations, such as in rigid metal conduit or in cable trays. However, bare equipment grounding conductors must be protected from physical damage and must be clearly identified as grounding conductors. The requirements for equipment grounding conductors are found in Article 250 of the NEC. Article 250 covers a wide range of topics related to grounding and bonding, including the types of grounding systems, the sizing of grounding conductors, and the installation of grounding electrodes. It is important to carefully review Article 250 before installing any electrical wiring or equipment. Proper grounding and bonding are essential for electrical safety. They help to protect people from electric shock and to prevent damage to equipment. It is important to understand the requirements of the NEC and to follow them carefully when installing electrical wiring and equipment. The NEC is a comprehensive set of rules and regulations that govern the safe installation and maintenance of electrical systems. It is updated every 3 years to reflect the latest advances in technology and the most current safety practices. The NEC is adopted by many states and local jurisdictions, and it is the standard by which electrical installations are judged. It is important for electrical contractors, electricians, and other electrical professionals to be familiar with the NEC and to follow its requirements. The NEC is not a design manual. It does not tell you how to design an electrical system. Instead, it provides the minimum safety requirements for electrical installations. It is up to the designer to ensure that the electrical system meets the needs of the customer and complies with all applicable codes and standards. The NEC is a living document. It is constantly being updated and revised to reflect the latest changes in technology and the most current safety practices. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and compliant. There are many resources available to help you learn about the NEC. The National Fire Protection Association, or NFPA, which publishes the NEC, offers a variety of training courses and publications. There are also many online resources available, such as websites and forums. By taking the time to learn about the NEC, you can help to ensure that your electrical installations are safe and compliant. Electrical safety is everyone's responsibility. By following the requirements of the NEC and by taking other safety precautions, you can help to prevent electrical accidents and injuries. Always work with a qualified electrician when installing or repairing electrical wiring or equipment. Never attempt to do electrical work yourself unless you are properly trained and qualified. Always disconnect power before working on any electrical circuit or equipment. Use appropriate personal protective equipment, such as gloves and safety glasses, when working with electricity. Inspect electrical wiring and equipment regularly for signs of damage or wear. Replace any damaged or worn wiring or equipment immediately. Never overload electrical circuits. Use extension cords safely. Never run extension cords under rugs or carpets. Never use extension cords to power appliances or equipment that require a lot of power. Keep electrical wiring and equipment away from water. Never touch electrical wiring or equipment with wet hands. Teach children about electrical safety. Explain the dangers of electricity and how to avoid them. By following these simple safety tips, you can help to prevent electrical accidents and injuries.